Alright, hi guys. This is going to be a review lesson on the substitution method. I just want to talk a little bit about what this is. You should have already learned this in Algebra 1 and you should be kind of good at it, but it's good to refresh. It's easy to forget some of these things. And basically what the substitution method is it's a shortcut for figuring out where do two lines on a graph cross. So this point right here, we call this on a graph the point of intersection. Point of intersection. And I just made this graph up. I didn't put any numbers on it. But if I want to know where do two lines cross each other, graphing it and finding okay, let's say this crossed at 2 and 1. So you'd say, oh, the point of intersection is at 2, 1, and you'd have an answer. But graphing can kind of be a slow way of doing things sometimes. Some graphs, what if it crossed at 10 and 37? You'd have to make this really big graph, or you'd have to scale it right to find that 10 and 37, and after a while that gets a little bit tedious and you don't want to do that anymore. So we need shortcuts, other ways of finding where do two lines cross, and one way is using the substitution method. So this is we're going to write a method of finding the point of intersection. A method of finding the point of intersection. Method of finding the point of intersection. Okay, so there's our definition. It's where two lines cross each other, finding that value, x and y value. So let's make up a problem. Let's say we've got these two lines and they cross somewhere and I want to know where. So let's say I have y equals 3x plus 1. That's a line. That's y equals mx plus b. And then I have this other line, maybe the equation's a little mixed up. Maybe it's 2y minus 4x equals 16. And I want to know, where do they intersect? Where is the intersection? So there's my question. I could, pull out my graphing skills, start graphing these two lines, and eventually figure out where the point is. And that would work. But we're trying this new method. We're trying the substitution method. So we're thinking shortcut. So here's the shortcut. I already know that y equals all of this. I'm going to circle this. 3x plus 1. Y, I'm going to bubble y here. Y and 3x plus 1 are equal to each other. They're the exact same thing. So if I'm looking at these and saying, okay, these are equal, and I've got a y in this other equation, I'm going to substitute in. That's where the name comes from. I'm going to substitute in for this y. I bubbled it. All three of my circles here are exactly equivalent. They're the same thing. So instead of a 2y, what I'm going to write is I'm going to write 2. And then I'm going to make a blank spot where the y was. And instead of putting y there, I'm going to fill it in with 3x plus 1. I'm going to substitute in. Then I'll copy the rest of the problem. We had a minus 4x. And an equals 16. Okay, there it is. Line down the middle, if you need a line down the middle. Let's solve this equation. So now it's really solvable. It's all in terms of x's. It's a distributive problem where you have to multiply 2 in. So 2 times 3 is 6x, plus 2 times 1 is 2, minus 4x equals 16. And then I see that I could probably take this plus 2 and move it over to the other side. So 16 minus 2 is 14. And then I have 6x minus 4x equals 14. 6x's minus 4x's is only 2x's. So 2x's equals 14. And if I split those 2x's up, divide them by 2, divide by 2, divide by 2, I get x equals. Split them up, I'm going to get 7. So I just figured out that if I go to x equals 7 on the graph, that's where my point of intersection is. Remember though, when you do this, so we got all this nice work, it was pretty quick, quicker than graphing. There's two answers to where it crosses. There's the x value and the y value. We've got, like in this example, I used 2 and 1. So I've only solved, in my shortcut, I've only solved for the x value down here. So I need to go over here and I need to solve for y. And to solve for y, I pick one of the equations from the start, one of these two. You can pick either one. the first one's probably easier, the y equals, because I want to solve for y and it says y equals, so it's kind of a one that would work well. And it was y equals 3x plus 1. I think I have an answer for x. I think it's 7. So again, I'm going to substitute. I'm going to put 7 there. I'm going to get rid of the x and change it to a 7. So I'm going to have 3 times 7 plus 1 equals y. And I'm going to do a little bit of math. 3 times 7 is 21 plus 1. Okay, so y equals 21 plus 1, so that's going to be 22. So I get my other answer, y equals 22. Now I got both my values. So if somebody said, well, where do these lines cross? You'd say, well, go to the graph, go over 7, go up 22, right there at that point. That's where they're crossing. So I'm going to write it like a point on the graph. 7, 22. And in general, we always do the x value and then the y value. So it goes in that order. So there's our answer, and that's kind of a quick review on the substitution method. We should practice one more because they can all look different, and some are easier than others. So I'm going to give you one last example, and I actually recommend you copy this and then pause the video and try it. Just to see, because if you can do this, then you know you remember your skills. So what if I gave you x equals y minus 6 and 3y minus 6x equals negative 12? Pause the video and see if you can solve using substitution. So where do these lines intersect? Okay, so I hope you paused the video. Now I'm going to go through this a little bit. We have an x equals this time. It's a little different than the last example. X is equal to all of this, y minus 6. So I'm going to circle the x. I'll bubble it is what I usually say. So these two things are equal to each other. X equals y minus 6. So I'm going to go down to the more messy equation and find the matching piece, and I see the x is right here. All three of these bubbles are the same exact thing. So we're going to substitute this x. We're going to change it to a blank spot, use parentheses, copy everything else. You know how there was a 3y minus 6? That's all still there. But instead of x, we have y minus 6. And it still equals negative 12. But now I'm ready to solve. Quick little line down the middle. Let's start doing the math. So let's see. We're going to have to distribute negative 6 in here and multiply it by both of these. So we're going to have 3y minus 6 times y is 6y. Negative 6 times negative 6 is a positive 36 equals negative 12. Careful with your signs. So plus 36. And then 3y minus 6y is negative 3y plus 36 equals negative 12. Move the 36 over, so make it a subtracting 36 minus 36, and combine these negative 12, negative 36, that's negative 48. So negative 3y equals negative 48. If you don't like the negative signs, you could flip-flop this whole problem, or just divide by negative 3, either way. And when you divide two negatives, make a positive. 48 divided by 3 is going to be 16, so we're going to have 16, y equals 16 as our answer. It's a good answer. It's not the whole answer because we want both variables. So what variable have I not solved for yet? X. I need to solve for x. So I'm going to have to go back to the start. And remember how you do this? You go all the way back to the beginning and you pick an equation, either the first or the second one. It actually doesn't matter which one you pick. This one's going to be easier because it's in the x equals format, so it's a simpler one. So I'm going to always pick the easy one. So x equals y minus 6. And I think I know the answer for y. I think it's 16. So I'm going to substitute in 16, bubble it in, and then copy the rest of the problem. X equals, now it's 16 minus 6. I probably didn't need a parenthesis because there's nothing in front to multiply by, so I could just write 16 minus 6 and forget about the parenthesis altogether. And 16 minus 6 is 10, so x equals 10. So I got my two answers. The lines are going to cross on the graph if I go over 10, up 16, so you got to think about where that is on the graph. And I can write it like a point because that's a crossing spot on the graph. So 10, 16. Always goes the x value and then the y value. So 10 and 16. So hopefully you got your answer right. This is just a review. You did lots of this last year in Algebra 1, but it's always good to practice. We don't want this to leave us. We want to remember this skill. See you in class.